Hey everybody, these are the notes accompanying homework number 6. There are also a couple other videos you can watch that I'll post on Canvas that are a little bit more kind of explanatory as to where all these things are coming from. But these are the ones that will help with the homework. So we're first going to talk about compound interest, and then we're going to talk about lines. For the compound interest, there's going to be a lot of calculator use here, so you will want to use a calculator to approximate these things. Well, let's talk about the formulas. So for interest compounded n times per year, the formula is A, the amount of money that we're going to end up with, equal to P, the principal, multiplied by 1 plus R over N, where R is still the interest rate as a decimal, but N is the number of times we're compounding. So if we're compounding annually, that's once a year, semi-annually is twice a year, quarterly is 4 times a year, monthly would be 12 times a year, weekly would be 52 times a year, daily would be 365 times a year, or minutely, every minute would be 525,600 times per year. That number goes there, and then T is still the number of years. On the other hand, if you want to find the amount of money you have if you're compounding interest continuously, or you have interest compounding continuously, that formula is A equal to P times E to the RT, where P is still the principal, R is still the interest rate, T is still the time, but E is the number 2.7 approximately that we've been talking about a little bit. So E is approximately 2.7. And if you want more information about why that's true, the other video that I'm posting below this is a good place to look. So let's look at some questions. Suppose we have invested $700 in a savings account. How much money would we have after 8 years if we get 4.75% compounded annually? All right, so let's just plug in all the numbers. We have our formula, A equal to P times 1 plus R over N to the NT. Our principal is $700. Our interest rate is 4.75%, but as a decimal, that's 0.0475 divided by the number of times we're compounding, but since we're compounding annually, that's just a 1, so I probably wouldn't usually write that, raised to the n times t, so 1 times 8. I would probably simplify this just a tiny bit before I try to put it into a calculator. So that's going to be equal to 700 times 1 plus a number is, I should say 1 plus a decimal that is between 0 and 1. You can just kind of write it as 1.0475 raised to the 1 times 8 is just 8 power. And that's about as simple as it gets without a calculator. So if I was asked to take a test or a quiz or an exam and asked a question like this would be my final answer. But if I was going to approximate it using a calculator, let's go ahead and do that. So I would do it in 2 steps probably. I would first do 1.0475 raised to the 8th power, and then I multiply that by 700. You could also enter it all at once. Whoops. And get about $1,014.68. And depending, so if we were going to round to the nearest dollar, I'd say it's $1,015. If we're going to round to the nearest cent, I'd say it's $1,014.68. So make sure this one doesn't specify. Make sure you read the question carefully about what you're being asked to round to. So we're going to say that's approximately $1,015 rounded to the nearest dollar. All right, let's look at the next couple questions, which are related. I feel a little like I'm a little, I feel like I don't sound great right now. Sorry. Not sick, just a little, I don't know, extra mouthy. So the next one's going to be the same idea, except now we're going to compound monthly with a 4.5% interest rate. So it's going to be the same formula, except now we're going to have that the amount of money is going to equal still the same principal, $700, 1 plus, but now the interest rate instead of being 0.0475 is going to be 0.045 divided by 12, because we're compounding it 12 times per year, right? That's going to be an n equal to 12 raised to the 12 times 8 power. And the only thing I can really simplify here, I mean, I can't simplify that. 0.045 divided by 12, I can't do that without a calculator really meaningfully. So I could write this as 700 times 1 plus 0.045 over 12. 8 times 12 is 96. So then I'm going to need a calculator. So again, this is my exact answer. And it's approximately equal to, let's get out the calculator here. So I'm going to do it all at once this time. So it's going to be, sorry, I want you to be able to see everything. Let me scooch this up a little bit. There's no one here to tell me that you can't see the thing, so I have to be very cognizant of what I'm doing. Yeah, the light's not too terrible. So there's a little bit of a glare right there, but it's not too terrible. I guess I can scooch over a tiny bit. Doesn't feel any better. I feel like, sorry. Okay, so anyway, we want 700 times, I want some parentheses, 1 plus 0.045 divided by 12, all raised to the 96th power. Well, not all. The 700 isn't getting raised because it's doing the power before the 700. So I should get $1,002. I should actually round up to 1,003 because the 0.6 rounds me up. It's approximately $1,003. Something you might notice as you do more of these problems is that usually a higher interest rate is going to give you more money than more often compounding. Although if this had been the same interest rate, in fact, let's go ahead and just look real quick here. If this had been the same interest rate as the previous one of 4.75, oh, here's a fun fact, by the way. With this calculator, if you want to do like the same thing you just did, but you don't want to like type it all again, here's what you can do. You can go, I did this before, and now I'm like, do I remember how to do it? I think you press enter. Nope, you don't press enter. What was it, James? It was really cool. There was like a directional button. Oh, you press this little up button here. So you go up and you go up, and then you press enter there. It gives you the same thing you wrote before, and now you can go edit it. So right, it gave me again 700 times 1 plus 0.045 divided by 12 to the 96th power. I'm going to change that 0.045 to 0.0475. So I'm going to insert a 7 right there. And now it's not the question that was being asked, but I'm just curious if I took my 4.75% interest rate and compounded it 12 times per year instead of 1 time per year, I'm going to end up getting $1,022, which is a little bit more than $1,015. Actually, I should say 1,023 because I should round up. So I just want to point out that the more frequently you compound your money or your interest, the more money you have at the end of your period of time. But here we were increasing the number of times we were compounding, but also decreasing the interest rate. So far, the better deal is to have 4.75% compounded only once a year, as opposed to 4.5% compounded 12 times a year. Okay, let's look at a few more examples here. So again, really, we're just using the same formula again and again and again. This time we're going to have the amount being still a principal of $700 times 1 plus, now it's going to be 0.0425 divided by, well, if we're compounding weekly, that's 52 times per year. And we're not going to worry about the fact that there's 52 weeks and 1 day in a year. We're going to divide by 52, and they're going to raise that to the 52 times 8. And then we would, I guess you could simplify this. I don't know. You could write it as 700 times 1 plus 0.0425 divided by 52. All to the 8 times 50 is 400, 8 times 2 is 16, so 416. And now I'm going to actually use the same trick I just did before. I'm going to say, I'm going to hit up to get that same entry I had, press enter. I'm going to go over here. I'm going to change the 96 to oops, I need to put the power again. I want the 96 now to be a power of 416. I want to be dividing not by 12, but by 52. That works out nicely. I can just replace the 1 with a 5. And it should be an interest rate of 0.0425. Looking good. Let's check. 700 times 1 plus 0.425 divided by 52, all raised to the, very fast there, 416 power. Ooh, much less. Interesting. So really decreasing that interest rate is having a lot more effect than compounding more frequently. So here we're getting approximately $983. I do like to put little boxes around my answers here. Okay. Finally, 4% compounded continuously. So here the formula is a little bit different. Instead of being A equal to P times 1 plus R over N to the NT power, that is not a formula for compounding continuously. For compounding continuously, the formula is A equal to P times 1. Sorry, I'm starting to write the wrong formula. Let's try that again. The formula for compounding continuously is A equal to P times e to the RT power. So in this case, that's going to be still my principal, $700, times E, which is just the number E, it's approximately 2.7, raised to the R times T, where R is our 4%, but as a decimal, that's 0.04, times the number of years, which is still 8. I could simplify this a tiny bit and get 700 times E to the 8 times 4 is 32, so 8 times 0.04 is 0.32. That's an exact answer. Decimal approximation is going to be, well, let's see here. Now, I don't want to use these previous formulas, so I'm just going to type in 700 times second e to the x, and then in the blank spot there, I'm going to put 0.32 or just 0.32. You get about $963.98. I'm going to round that up to 964. Cool. How long? Oh, okay, it's already 10 minutes. All right. This video is going to be a little lengthy. Sorry about that. So let's look at the next example. Most of these questions are just about kind of like with the regular simple interest, taking all the pieces that we can plug into our formula and solving for the unknown quantity. So here the question is how long? So we're going to solve for time. Will it take $300 to triple in an account paying 5% interest compounded? And then we have different options here. I feel like this looks kind of so. In this problem, we know that our principal is $300. We want it to triple, so we want our amount to be $900. The account is paying 5% interest, so our R value is 0.05. So for compounding semi-annually, our N is equal to 2. So plugging everything into that formula, I don't want to keep writing that formula over and over again, so I'll just write it over here. It's A equal to P times 1 plus R over N to the NT power. So here I'm going to have 900 equal to 300 times 1 plus 0.05 over 2 to the 2 times T power. So now my job is to solve for T. Specifically, when you have a variable in your exponent, that's when we almost always have to use a logarithm. Any other time, like if you're solving for the principal here, solving for the interest rate here, you can usually avoid using a logarithm. But for the variable in the exponent like that, you have to use a logarithm. So first divide both sides by 300. So 900 divided by 300 is equal to 1 plus, I can simplify this. 0.05 divided by 2 is 0.025. That's not always something that simplifies easily. Here it does. 900 over 300 is 3. So now I'm going to take the natural log of both sides. So I have the natural log of 3 equals the natural log of 1.025 to the 2t power. The reason we did this is so that we can bring the 2t power down in front of the natural log. So now we can rewrite this as the natural log of 3 equal to 2t times the natural log of 1.025. And it's a little close for my taste there. Sorry about that. And then we're going to isolate t by dividing both sides by 2 and by natural log of 1.025. So we're going to say that natural log of 3 divided by 2 times the natural log of 1.025 is equal to t. Again, not only should we use a decimal approximation because we're going to be asked to, but also because it's not a very meaningful answer if we leave it like this. I don't know, like, is that 1 year, 7 years, 1,000 years? Like, I have no idea what that is until I actually use a calculator. So using a calculator, I'm going to get natural log of 3 divided by parentheses 2 times natural log of 1.025. Close those parentheses, and then we get about 22.24 years. Let's say we need to round to the nearest tenth of a year. So that's going to be approximately 22.2 years. All right, same idea, except now it's going to be quarterly. I want to point out that each time if we're trying to see if it triples, our first step is always going to be to divide by whatever this is here, and we're going to get 3 on the left. So certainly we could start with 900 equal to 300 times 1 plus 0.05 divided by 4. to the 4 times t. But then the first step is to divide both sides by 300 and get 3 on the left equal to 1 plus 0.05 divided by 4 is, let's see, I think it's 0.0125. So I have a 1.0125 to the 4t power. Take the natural log of both sides. Natural log of 3 equals natural log of 1.0125 to the 4t power. Bring down the 4t in front. Natural log of 3 equals 4 times t times the natural log of 1.0125. Rewrite it as natural log of 3 divided by both 4 and natural log of 1.0125. That's going to be equal to t. Now, if you use a calculator, same kind of expression here. In fact, no, let's just write it again. It's pretty easy to calculate. That's going to be the natural log of 3 divided by 4 times the natural log of 1.0125. 22.1 years, so slightly less time. And again, that makes sense with my idea of what's happening here. Whoops, I don't know why sorry, something happened with my video quality here. One moment. Okay, it's back. So what I was saying is that makes sense with my idea of the more frequently you compound, the faster your money grows, or the less time it takes for it to get to the amount you're trying to get to. Again, not a lot less time here, right? A tenth of a year is barely more than a month, but still, every minute counts. All right, let's look at this last question for this part. So now we want to know how long it takes to do it if we're compounding it continuously. So now our formula is going to be, instead of a equal to p times 1 plus r of n to the nt, it's going to be a equal to p e to the rt. So a is still 900. Our principal is still 300. E is just e. R is 0.05, and we're trying to solve for t. So again, divide both sides by 300. So we get 3 equal to e to the 0.05 t. Take the natural log of both sides. Natural log of 3 equals natural log of e to the 0.05 t. Bring down the 0.05 t. I don't know why so parentheses here or here, it doesn't really matter. So I've got the natural log of 3 equal to 0.05 t times the natural log of e. I'll point out, why is my video stopped? What is going on? Sorry. Very frustrating here. What's going on, video? What's your problem? My document camera is like, sorry, real quickly, I guess I'll close this here real quick. Okay, let me open it back up. Sorry for the interlude here. There we go. Okay, back in business. So, as I was saying before my document camera decided to be such a pain, is that the natural log of e is log base e of e, which is 1. Oh, you know what? I need to make sure I'm sharing my screen. Don't want to forget to do that. Sorry. So what I was saying is, in this equation here, a natural log of 3 equals the natural log of e to the 0.05 t. I brought down the 0.05 t and said natural log of 3 equals 0.05 t times natural log of e. And then it's really, really important to remember that the natural log of e is equal to 1, just like log base 5 of 5 is equal to 1, just like log base 7 of 7 is equal to 1. So then we can just solve for t by dividing by 0.05. So t is equal to the natural log of 3 divided by 0.05. Here I would mention that dividing by 0.05 is dividing by 5 over 100, which is like multiplying by 100 over 5, which is like multiplying by 20. So if you wanted to, you could also say that this is t equal to 20 times the natural log of 3. In either case, I'm going to use the calculator. I don't really want to use those decimal approximations, even though I know that the natural log of 3 is about 1.1. I'm guessing my answer here is going to be about 22 even. So let's find out. So 20 times natural log of 3 is, I should have said 22 even, sorry. 1.1 times 20 is 20 times 1.1, which is 20 plus 2, which is 22. And this would be, yep, rounding up to the nearest year, it would be 22.0. So it's approximately 22.0 years. You don't really need the 0.0 there, but I kind of like it. I'll point out that this would have been the same as doing the natural log of 3 divided by 0.05. Same exact answer. Great. All right, let's continue on. I don't know why this page is blank here. No, I know. Okay, sure. So, oh my gosh, document camera killing me. So, how much money would I have to invest in an account that pays 7% interest compounded continuously to have $10,000 in 6 years? So we're just filling in all the pieces of the formula. So we want to know how much money I would have to invest. So the question is, what's the principal I would need? So the P should be the thing that's the variable here. I know I want to have an amount of $10,000. I want it to equal the principal times 1 plus my interest rate, which is 0.07, divided by the number of times I'm compounding it. Oh, I'm compounding. Should have read the question more carefully. I'm compounding continuously, so I don't want this version of the equation. I want 10,000 equal to P times E to the R, which is 0.07, times T, which is 6 years. Sorry about that. That's why it's important to read the question. So I'm going to solve for P here. I don't have to take a natural log or anything like that. I just have to isolate P by dividing by this. So I'm going to rewrite this as 10,000 equal to P times E to the 7 times 6 is 42. So 0.07 times 6 is 0.42. And I can just divide both sides by E to the 0.42 and get 10,000 divided by E to the 0.42. You don't really need those parentheses there, but I kind of like them. Equal to P times E to the 0.42 divided by E to the 0.42. Those divide to 1. So you end up getting that P is equal to 10,000 divided by E that to the 0.42. Or if you like, and I kind of do like, gosh, why does document camera keep freezing? I am so sorry. This connection is just not lovely. I don't know what's going on there. Sorry. So you could say you have 10,000 divided by E to the 0.42, or you could say that you have 10,000 times E to the negative 0.42. Oh my God, document camera, what is your issue? It keeps freezing up. Either way, if I do this, 10,000 divided by E to the 0.42 is about $6,570. And let's just say we want to round it to the nearest dollar. So it's going to be about $6,570. And it makes sense that we should have to start off with less than we're trying to get to, right? If we're earning interest. Just so everyone's clear with this, I could also do 10,000 times E to the negative 0.42 and still get the same exact result. So either way of doing it is fine. Remember, dividing by E to a positive power or anything to a positive power is equivalent to multiplying by that same base to the corresponding negative power. All right, another example. This might be the last. No, there's a couple more. And then this is the last interest problem. And what, sorry about all the pausing here. Document camera is on. Hopefully it stays on. So last interest question, then we're talking about graphing some lines. 6 years ago, I invested $3,000 into an account that paid interest bi-monthly. It's once every 2 months, so my N is going to be 6. Today, the account is worth $5,127.42. What was the interest rate? Okay, so again, I'm just plugging everything into that formula. So my my amount is equal to my principal times 1 plus R over N to the NT power. I'm going to plug in 5,127.42. That's kind of a very specific number there, but I want to make it turn out nice. The principal is $3,000. The R value is what we're trying to find. The N value is the number of times we're compounding, which is 6 times per year, right? N equals 6 if we're compounding every 2 months, and there's 12 months in a year, so there's 6 2-month periods. Raised to the power of 6 times 6. 6 for the number of times we're compounding and 6 for the number of years. And I don't love that I made that those the same, but I happen to do that. And so that's what we get. So now we're trying to solve for R. And just like the previous problem, we don't really have to use, we don't have to use at all a logarithm. You could use a logarithm here, but it's usually better not to if we don't have to. So I'm trying to solve for R. So here's what I'm going to do. And this is going to look a little bit messy. I'm not going to lie. So I'm going to divide both sides by 3,000 and get 5,127.42 divided by 3,000 equal to 1 plus R over 6 raised to the 6 times 6 is 36th power. This might simplify. I don't know. Let's find out. Let's see if it simplifies nicely or if it's going to be terrible to write down. If it's terrible to write down, I might just leave it as it is. Because usually you don't want to approximate things until the very end of the process. Oh, that's not the worst thing I've ever seen. I might just write that down since it is an exact value. So I'm going to say we have 1.70914. Kind of got lucky there. If that decimal had gone on and on forever, it would be an approximation, and I don't want to approximate unless I have to. But here, this is an exact value, so it's fine to write this down. So that's going to equal 1 plus R over 6, all raised to the 36th power. I'm going to take the 36th root of both sides. So I'm going to get the 36th root of 1.70914. Or you could raise both sides to the 1 over 36th power equal to 1 plus R over 6. I could write to the 36th and then the 36th root of that. We should know that those undo each other, so you just get 1 plus R over 6. So we've got 1 plus R over 6 is equal to the 36th root of 1.70914. And then finally, we have R divided by 6 equal to this number. And I'm running out of room here. 36th root of 1.70914 minus 1. And then to solve for R, we're going to multiply both sides by 6. So my interest rate is going to equal 6 times the 36th root of 1.70914 minus 1. And then we should get an approximate value. So let's plug this in. So we've got our 1.70914 here. And we're going to take the 36th root of that. So doing a root, you can do it on a calculator. You can do the second. You can do, oops, I always got that wrong. You can do 36 and then make it the root of your previous number, very close to 1. Or you could do it a different way. You could say, I'm going to take that number 1.70914 and raise it to the 1 over 36 power. Same result, 1.015000. So then here's what we've got. We've got that R is approximately equal to 6 times 1.015 minus 1, which is just 6 times 0.015, which is 0.09. Or as a percentage, 9%. Cool. All right. So that's all I really have to say about continuous. Well, that's all I have to say here about continuous interest, continuously compounded interest, and just compound interest and continuously compounded interest. If you want more information about that, you should really go check out the videos that I have also posted next to this. Get other notes here. Yeah, cool. So let's talk about lines. So there's lots of things to do with lines. One of the things we mostly do with them is graph them. And usually the easiest way to graph a line is to find the y-intercept and the x-intercept and draw the line that goes through them. There are some exceptions to that. There are some graphs that don't have a y-intercept and an x-intercept, or the y-intercept and the x-intercept are both the same point. This one's not that case, though. So we'll deal with the kind of more regular cases first, and we'll talk about the special cases in a minute. So I want to point out, and I'm going to draw the graph over here. There's my x-axis, there's my y-axis. Oops, you can't quite see that. So if I'm on the y-axis, my x value is 0 because I haven't moved left or right. Similarly, if my point is on the x-axis, my y value is 0 because I haven't moved up or down. So to find that, I usually start with the y-intercept. To find the y-intercept, I'm going to set x equal to 0 in my equation. So I'm going to get y equal to 2 times 0 minus 3. So y is equal to 0 minus 3, so y is equal to negative 3. So my y-intercept is the point where x is 0 and y is -3. I don't particularly like to make little marks showing where things are, but we can do it that way, but I'm probably not going to here. So then, maybe I will. To find the x-intercept is usually a little bit more work. The same idea. To find the point on the x-axis where this graph is going to cross it, where this line is going to cross it, I'm going to set y equal to 0 because I know the y coordinate has to be 0. Just like here, I know the x coordinate is 0. So this point here is the point 0, -3. I haven't moved left or right. I've gone down 3. X-intercept, I'm going to set y equal to 0. This usually involves a little bit more actually solving an equation. So I have 2x minus 3 equal to 0. Add 3 to both sides. 3 equals 2x. Divide both sides by 2. 3 over 2 is equal to x. So x is either 3 halves or 1.5. So my x-intercept is the point 3 halves comma 0. So it's halfway between 1 and 2. It's right there. And then if it were up to me, I would probably use a straight edge if I had one. I just realized I haven't been sharing my screen. Well, let me talk back through the problems there that I feel like I wasn't sharing my screen for. Remember exactly what they were, but just so everyone can see what I was saying before, you can also follow along in the notes. Um, I think we got cut off like right about here. So I think I kind of forgot to do all of this here. Apologies. So I said all the words. I'll say them again. So I invested $3,000 into an account that paid interest bi-monthly. That's once every 2 months. So our N is 6. Today the account is worth this much money. What was the interest rate? So we set A equal to 5,127.42. Our P is 3,000. Our R is what we're trying to find. Our N is 6. And then both our N and our T are 6, which I know is kind of weird, but that's what we got. So then we calculated it. We divided both sides by 3,000. We actually did the division and it turned out to be a nice number, right? It was a non-terminating decimal. So if you actually calculate that, 5,127.42 divided by 3,000. Oops, turn on the calculator maybe. Turns out to be exactly 1.70914. So then we had 1.70914 equal to 1 plus r over 6 to the 36th power. We took the 36th root of both sides to get 1.70914 equal to the 36th root of 1.70914 equal to just 1 plus r over 6. We subtracted 1 from both sides. We multiplied both sides by 6. And then we got a decimal approximation by doing the 36th root of that, or the 1 over 36 power, and then subtracting 1, and then multiplying by 6. And 0.09 is our decimal, but the percentage is then going to be 9%. Sorry about that. Let's talk through this line as well. So I was talking about how to graph a line, we need to find the y-intercept and the x-intercept and draw the line through them. So we're trying to graph y equal to 2x minus 3. The way we find the y-intercept is by setting x equal to 0, because if you're on the y-axis, your x value, you didn't move left or right, your x value is 0. So we set x equal to 0, we plug in 0 for x, we got 2 times 0 minus 3, which is 0 minus 3, which is -3. So our y-intercept is -3. Similarly, to find our x-intercept, we set y equal to 0, because if you're on the x-axis, you haven't moved up or down. So then setting y equal to 0, we get 0 equal to 2x minus 3, or adding 3 both sides, we get 3 equal to 2x, or divided by 2, we get 3 halves equal to x. So our x value is 1.5, our x-intercept is 1.5 comma 0, or 3 comma 0. So there's my x-intercept right there, 3 halves comma 0. And then I'm going to grab a straight edge to make my line look pretty. And I'm going to draw the line that just goes through those 2 points. And since it's worth noting here, I will also point out something about the slope for a second. So the slope of this line is 2. And typically when you have a y equals something times x plus or minus a number, the slope is the coefficient of x. That's only true though if it's y equals some stuff. If you have the equation set up differently, it might not be true. Here the slope is 2, which means every time you go over 1, you go up 2. So this point here is the point 1 comma -1. So I've gone over 1 and up 2. And if I did that again, over 1 and up 2, this point here would be the point positive 1, comma 1. So, oh, no, sorry, positive 2, apologies, comma 1. Right? X increases by 1, y increases by 2. X increases by 1, y increases by 2. So the slope is just how much y increases for every 1 unit that x increases. So x goes from 0 to 1, y increases by 2. X goes from 1 to 2, y increases by 2. The next one would be 3, comma 3. The next one would be 4, comma 5. Every time x goes up by 1, y goes up by 2. Let's look at some more examples. Let's graph y equal to negative 3x plus 4. So here the slope is going to be negative 3, meaning every time x increases by 1, y is going to decrease by 3. We're still going to graph it the same way. We're still going to graph it by finding the y-intercept and the x-intercept. So y-intercept, we're going to set x equal to 0. We're going to get y equal to negative 3 times 0 plus 4, which is just 4. So my y-intercept is the point 0, comma 4. My x-intercept is going to be a little bit more work. I'm going to set y equal to 0. I'm going to get 0 equal to negative 3x plus 4. I'm going to add positive 3x to both sides to get positive 3x equal to positive 4, and then divide both sides by 3 to get x equal to 4/3. So my x-intercept is 4/3, comma 0. Now I'm going to graph it. I don't need that for that. Doesn't have to be perfect. Just try to do the best we can. So my y-intercept is negative 4. I'm going to go down 1. Sorry, negative 4, positive 4. 1, 2, 3, 4. My x-intercept is 4/3, which is 1 1/3, which is a little bit between 1 and 2, but it's closer to 1. So this is actually where it's kind of nice to use the slope. So I know that if I go from the point 0, 4, if I go over 1, I should go down 3. So I'm going to plot this point here, even though it's not really the point I care about plotting. And then I'm going to draw the line through those 2 points first. So my line's going to look like that. And then I can say, because really, when I ask these kinds of questions, I usually like to label, and I usually want students to label the y-intercept and the x-intercept. There's your y-intercept at 0, 4. Here's your x-intercept at 4/3, comma 0. And hopefully you all can see that. Let me zoom in. I'm risking it here, moving this around. There's your graph where the y-intercept is 0, 4, and the x-intercept is 4/3, comma 0. Cool. Let's get that a little bit better. Sorry. Okay. So that's the idea for graphing lines. You find the x-intercept, you find the y-intercept, you draw the line through them. Let's do this next example, which is a little bit different. It's still a line, but it's not written in the usual y equals mx plus b form, also known as the slope-intercept form. It's written in the ax plus b y equal to c form, which is the general form. So I should actually maybe say that here, right? This is the y equals mx plus b, also known as the slope-intercept form, because literally when you look at it, you can see what the slope of the graph is and what the intercept of the graph is. The slope is negative 3, the m, and the y-intercept is 4, which is the b. Here, this form doesn't tell you really anything, actually. This is called the general form. It's ax plus by equal to c, and that's the general form. And the issue here is that it doesn't actually tell you what the slope is or what the intercepts are. We can still find the intercepts, though, in the same sort of way. And I want to stress here, we do not have to solve for y to be able to to be able to graph the thing. So if I find the y-intercept, I'm going to start the same way by just setting x equal to 0. So I set x equal to 0. I'm going to get 3 times 0 plus 2 times y equal to 12. 3 times 0 is 0. So I have 2y equal to 12. Divide both sides by 2. And y equals 12 divided by 2, which is 6. So my y-intercept is 0, comma 6. When you're writing a point, by the way, it's always the x-coordinate first, the y-coordinate second. It's in alphabetical order. And then to find the x-intercept, same deal. Or I should say similar deal. I'm going to set y equal to 0. I'm going to say 3 times x plus 2 times 0 equals 12. So 3x equals 12, and divide both sides by 3. X equals 12 divided by 3, which is 4. So my intercepts are 0, 6 for the y-intercept and 4, 0 for the x-intercept. So graphing this, I'm going to try and be very precise here. Yeah. So I'm going to go 1, 2, 3, 4. I know I said before I don't care about doing this, but I want the picture to look good for you all. So there's my y-intercept is 6, my x-intercept is 4, and graphing the line through those points. Look like that. I want to point out here, the slope of this line certainly isn't the coefficient of x in my equation. The slope is not positive 3. Slope isn't positive 2. The slope is actually negative 3 halves, I think. Yeah. This point here is 0, 6. This point here is 4, 0. If you wanted to find the slope, well, another way of thinking of the slope is the rise over the run, or the change in y divided by the change in x. Here, the slope is this y coordinate minus that y coordinate over the corresponding x coordinate minus the corresponding x coordinate. So it's equal to 6 over negative 4, which is negative 3 over 2. So my slope here is negative 3 halves. And the more general formula for finding the slope is slope between 2 points is the difference in the y's, also known as the rise, over the difference in the x's. I know we weren't asked about slope in this problem, but it seemed like an opportune moment to talk about it. Let's look at a few more things. And I know there's a few more pages, but we're actually kind of closer to them than you might think. So if I want to graph what I call special lines, really they're special because they're kind of annoying. If I want to graph y equal to 2x, my intercepts are both the origin. If you set x equal to 0 to find the y-intercept, you're going to get y equal to 2 times 0, which is 0. Similarly, to find the x-intercept, if you set y equal to 0, you're going to get 0 equal to 2 times x, and then 0 divided by 2 is going to be 0. So you're going to get x equal to 0. So you only have one point, which is the origin. When that's the case, and you're, like in this case, our line has a slope of positive 2, then I'm just going to plot another point. So I know that if x is 1, my y value is going to be 2. So I get the point 1, comma 2. And I can draw the line through those 2 points. Like that. And again, I just want to point out, we're going over 1, up 2. Our rise is 2, our run is 1. So our slope is our rise over our run, which is 2 over 1, which is 2. I'm actually going to change this next one just a tiny bit. I'm going to make it the graph of negative 1/3 x. So this one, the same idea holds. My y-intercept and my x-intercept are both going to be the origin, which I guess I could have written right here. Here the y-intercept is 0, comma 0. Here the x-intercept is 0, comma 0. And that's true for lines. If one of the intercepts has an origin that if either the x-intercept or the y-intercept is the origin, then so is the other one. So the line can only have one x-intercept, with a very rare exception. Okay, and one y-intercept as well. So same deal here. I know I'm going to have a line that goes to the origin, my y-intercept. If I set x equal to 0, I'm going to get y equal to 0. And so I'm going to have the point 0, 0. The same sort of deal here. And now I'm going to try to pick a convenient value for x. So picking x equal to 1, although I get y equal to negative 1/3. It's kind of annoying to graph. I'd rather pick x equal to 3. So if x equals 3, I'm going to get y equal to negative 1/3 times 3, which is just negative 1. So I get the point 3, comma negative 1. And that's going to make it easier to graph this thing. Where if I'm instead of trying to kind of guess where negative 1/3 lives exactly, it's much easier to pick an integer value. There's my line. We do draw little arrows at the end of the line to indicate that it keeps on going. This is the line y equals negative 1/3 x. I will point out that when a line goes up from left to right, the slope is positive. And when a line goes down from left to right, the slope is negative. And also point out again here, right, my run is 3, my rise is negative 1, right? I've gone over 3 and down 1. So my slope is my rise over my run, which is -1 over 3, which is -1. Okay. So when you have lines whose intercepts are both the origin, you kind of have to find another point to be able to graph it well. And I guess I could label these other points, right? This other point is the point 1, comma 2 up there. This other point here is the point 3, comma -1 down here. Let's look at a couple other special lines, like y equals 3. So for y equals 3, it's kind of annoying, but it's also totally fine. So if y equals 3, x can be anything. So for example, if x is 0, there isn't even a place to plug in x equal to 0. I'm going to get y equal to 3. And if x is, say, I don't know, 4, well, I still get y equal to 3. So no matter what value I pick for x, y is always going to be 3. So I get a line that's a horizontal line that passes through all the points where y is equal to 3. Whoops, don't tilt your thing, James. Sorry about that. I'm terrible. Like that. So there's the line y equals 4. Y equals a number is always going to produce a horizontal line. In a similar way, graphing x equal to a number is always going to produce a vertical line. So if x is -2, y could be 0. You have the point -2, 0. But y could be anything. I could get the point where y is 3 and x is still -2. Because no matter what I pick for y, the x value always has to be -2. So here my line is a vertical line. X equals -2. There's really not a lot to be said about vertical lines and horizontal lines, other than you get a vertical line when x equals something, you get a horizontal line when y equals something. I will also point out, though, that horizontal lines and vertical lines are perpendicular to each other. And there's kind of a thing about perpendicular lines that these two lines don't satisfy, which I'll say in a minute here. All right, I'm trying to wrap this up. I know there's a few more pages, but it's really not. Oh, yeah, there's still, okay, there's still one more thing to do. So find the equation of the line passing the point 1, comma 3 and 5, comma -5. So let me show you kind of the fast way to do it and then kind of talk about where it's coming from. So to find the equation of a line, you need two things. You need a point, which we have more than one of, and we need a slope. And the way you find the slope is by finding the difference in the y's over the difference in the x's. So I can find the slope here by either calculating, and again, I'll point out this is x1, y1, this is x2, y2. So I could either do it as -5 minus 3 divided by 5 minus 1, which is -8 divided by 4, which is -2. But it actually doesn't matter which order you're subtracting. So you could also do it as y1 minus y2 divided by x1 minus x2, which is going to be 3 minus -5 divided by 1 minus 5, which is +8 divided by -4, which is still -2. So either way you calculate the slope, you're going to get the right thing. Doesn't matter which order you subtract them. It doesn't matter if the y's are on top and the x's are on the bottom, because it's rise, the change in y, over run, the change in x. So now there's two ways to do this. My preference is to use what's called the point slope form, which is that we say y minus the y coordinate equals the slope times x minus the x coordinate. This is called the point slope, where you have a point and a slope and you throw it into this formula. So in this case, I would say that y minus one of the y values, and we'll talk about how we're going to pick in a second, equals your slope, which is -2 times x minus one of the x values. And now you can pick either pair. You can either pick x and y to be 1 and 3 or x and y to be 5 and -5. Let me show you how it works the same either way. So I pick x and y to be respectively 1 and 3. Let's see how this works out. I'm going to simplify it to isolate y. So I'm going to get y minus 3 equals -2 times x minus 1. I'm going to distribute the -2 and get y minus 3 equals -2x plus 2. Then I'm going to add 3 to both sides and get y equal to negative 2x plus 5. If I had picked the other point to plug in, say the 5 and negative 5 for x and y respectively, I'd get the following. Y minus the y value, which is negative 5, equal to negative 2 times x minus the corresponding x value, which is positive 5. Let's see if we get the same result when we simplify. So I have y plus 5 equal to negative 2 times x minus 5. Distributing the negative 2, I get y plus 5 equal to negative 2x plus 10. Subtracting 5 from both sides, I get y equal to negative 2x plus 5. Yay, it's the same thing. Or thirdly, I could do it the way that is not my favorite, but it's totally fine. I could start with, so you can do it this way, you can do it this way, or you can do it this way. Maybe I should use different numbers. You can do it this way, or this way, or this way. You can start with y equals mx plus b. Plug in your value for m. It's going to be y equals negative 2x plus b. And then pick either one of these points to plug in for x and y. So I plug in 1 for x and 3 for y. I'm going to solve for b. So I plug in 1 for x and 3 for y. Well, then I have 3 equal to negative 2 plus b. I add 2 to both sides, and I get 5 equal to b. So then I plug that back in for b here, and I get y equal to negative 2x plus 5. So any way you slice it, you're going to get y equal to negative 2x plus 5 when you write it in a slope-intercept form. Cool. So let's look at a couple more examples, and then we'll wrap it up. So find the equation of the line passing through these 2 points. So again, we're going to find the slope. The slope is going to be the difference in the y's over the difference in the x's. So 5 minus, sorry, I just write the equation here. It's going to be 5 minus 3 over 1 minus negative 2, which is going to be 2 over 3. And then I'm going to write y minus my y coordinate equal to my slope times x minus my x coordinate in parentheses there. So you're going to have y minus, take your pick. I'm sorry, take your pick. If I have a choice here, I usually try to pick, if I have a choice between all positive and some negative, I usually prefer all positive. So I'm going to have y minus 5 equal to 2/3 times x minus 1. By the way, down here, if you're looking for it, this is the access code for homework number 6. It is capital S, lowercase p-a-r-y, and the number 6. So we have y minus 5 equal to, we're going to distribute the 2/3. It's 2/3 times x. Minus 2/3 times 1 is just minus 2/3. Then we're going to isolate y. We get y equal to 2/3 x minus 2/3 plus 5. Get a common denominator over here. So you have y equal to 2/3 x minus 2/3 plus 5 over 1 times 3 over 3 is 15 over 3. So you have y equal to 2/3 x, and then negative 2/3 plus 15/3 is plus 13/3. Again, if you're looking for the access code for the homework 6 to start doing it before Monday, it's capital S, lowercase p-a-r-y, and then the number 6. No spaces, just that. All right, a few more line equations that have a little bit different deal. Find the equation of the line parallel to y equal to negative 3x plus 7 that passes at the point 5, negative 2. So the nice thing about parallel lines is they have the same slopes. So we know that the slope of this line is negative 3. So the slope of our line is negative 3. And now we're just going to do the same sort of thing as before. We're going to say y minus the y coordinate equals our slope times x minus the x coordinate. So y minus negative 2 equals 5 times x minus 3. Y plus 2 equals 5x minus 15. Y equals 5x, and minus 15 minus 2 is minus 17 because it got more negative. Or if you want to do it the other way, the y equals mx plus b way, you can say y equals negative 3x plus b, plug in your point. So negative 2 for y, positive 5 for x, negative 2 equals negative. I feel like I feel like I'm about to make a mistake here. Don't want to make a mistake. I did make a mistake here. I wrote 5 here when it should have been negative 3. So let's finish doing it this way and then we'll come. So let's actually finish it off and see what happens. So negative 2 equals negative 15 plus b. You add negative 15, you get positive 13. So we have 13 equal to b. So here we're getting the equation y equal to negative 3x plus 13. And then we look and we say, oh, those aren't the same. They should be the same. And then we're like, oh, which one of these is wrong? This one's wrong. We used the wrong value for the slope, right? Parallel lines have the same slope. So if the slope here is 3, sorry, negative 3, and the slope of our line should be negative 3. So this was incorrect. Let's try it again. So we have y minus y1 equals m times x minus x1. And we should have y minus negative 2 equal to negative 3 times x minus 5. Yeah, I clearly interchanged the 5 and the negative 3 for the x coordinate and the slope. Sorry. Y plus 2 equals negative 3x plus 15. Subtract 2 from both sides, you get y equal to negative 3x plus 13. Much better. Now they match. All right. Apologies for the length of this video. It is longer than I wanted it to be. Last one. Find the equation of the line perpendicular to 4x minus 3y equals 24 that passes through the point 5, 3. So parallel lines have the same slope. Perpendicular lines have slopes that are opposite inverses. So I'll just point out here, we use this symbol for perpendicular often. Perpendicular lines have slopes that are opposite, meaning negatives of each other. So one is positive and one is negative. Inverses, meaning reciprocals. So for example, this line, y equals 2x plus 1, and this line, y equals negative 1/2 x plus 3, are really, the last minute here, the last minute the screen thing is acting up again. Sorry, a moment, please. This video feels just a little cursed. Okay, let's try that again. Let me share my screen again before I start saying words about what I think you're seeing. Okay, there we go. So we are finding the equation of the line perpendicular to 4x minus 3y equals 24 that passes to the point 5,3. And I was talking about how this symbol means perpendicular, because usually you draw it a little more right angly. Perpendicular lines have slopes that are opposite inverses. So these two lines, y equals 2x plus 1 and y equals negative 1/2 x plus 3, are perpendicular because the slope here is 2 and the slope here is negative 1/2. And since those numbers are opposite signs and reciprocals of each other, we see that they are perpendicular. You could also graph them both. So if you graph y equals 2x plus 1, it looks like this. It's got a y-intercept of 1. It's got an x-intercept of negative 1/2, and then another intercept of 3 here. So that graph looks like this. Just to point out, they really do look perpendicular. So there's y equal to 2x plus 1. And then negative 1/2 x plus 3 has a y-intercept of 3, has an x-intercept of 6. If you graph that, it's going to look like that. Right? So my scale here is a little off. Apologies. But I promise you, that these are perpendicular to each other. So these should have been a little bit longer to get to 6. Or 1, 2, 3, 4, 5. Yeah, sorry about that. This is why I don't like making those marks. If I kind of just cross that out here, really, that would be like 1, 2, 3, 4, 5, 6. That looks a little bit more reasonable. Sorry for the ugliness there. So for the lines to be perpendicular, the slopes have to be opposite inverses. Or another way to say that is the slopes have to multiply to -1. So I'll point out here that 2 times -1/2 is equal to -1. Another example, which I'm not going to graph, would be the following. Y equal to 2/3 x plus 3, and y equal to -3/2 x minus 1. Those are also perpendicular because their slopes are either opposite inverses or they multiply to -1. The trick for this one, for this example, is that the original equation, 4x minus 3y equal to 24, the slope is not immediately obvious. To be able to find the slope, we really should solve for y. So isolating y, we're going to get -3y equal to -4x plus 24. And then dividing both sides by -3, we're going to get positive y equal to positive 4/3 x minus 8. So the slope of this line is positive 4/3. So the slope of my perpendicular line is -3/4. The point they gave us was 5, 3. That doesn't change. So the point we're given here is still 5, 3. So now we have all the information we need to find the equation of the line. We have the point, we have the slope. I'm going to use the point slope formula. So y minus 3 equals -3/4 times x minus 5. And then I'm going to simplify it and get it in the slope intercept form. So I have y minus 3 equal to -3/4 times x. -3/4 times -5 is -3/4 times -5/1, which is 15/4, and it is positive. I'm going to add 3 to both sides. So y equals -3/4 x plus 15/4 plus 3, which is 12/4. And then I'm going to simplify and get finally y equal to -3/4 x plus 27/4. Okay, there you go. So there's hopefully all the information you need, or enough information to successfully handle homework number 6. Bye.